So in this class, we are looking at bonds in methane. We need to look at bonds in alkanes, and bonds in alkynes. But we are going to take them in separate classes. So in this one, we want to look at bonds in alkane, and majorly we are going to talk about methane alone. So because for this syllabus, we are not going to talk more than methane. And if you can know bonds in methane, you can know virtually all the bonds that can occur in all other alkane homologous series. So how do we represent methane in the first place? Methane is represented by C, then hydrogen, 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 hydrogen. The question now is this. This is a bond, it is a covalent bond. But if you want to ask, why is it covalent bond? Yeah, that one is very easy to understand because you have been taught that one in your O-level chemistry. Once you have a bond being formed from electrons contributed equally by two atoms, especially non-metals, you don't have any other thing you will get there other than covalent bond. But the type of covalent bond present here, whether it is sigma bond or pi bond, is what I want to explain. All right. If you want to represent the electronic configuration of hydrogen, it is represented as 1s1. That means the only orbital in hydrogen is s orbital. That's the only orbital in hydrogen, s orbital. There's no any other orbital again in hydrogen. All right, so that means we don't have any problem with hydrogen. But remember that in carbon, in my first video, I wouldn't know if it is first video or second video, I explained what is called hybridization. And we have shown in that video that hybridization brings about manipulation to carbon atomic orbitals, so that the four unpaired electrons present in carbon are now sp3. They are now sp3. So if they are now sp3, then there will be a modification to definition of sigma bond. All right, let's see. This is sp. Okay. This carbon is using sp3 1 for this hydrogen, sp3 1 for this hydrogen, sp3 1 for this hydrogen, sp3 1 for this hydrogen as well, which simply means all the bonds in methane are identical. Now here we have this as sp3 contributed by carbon atom. We have S1 contributed by hydrogen atom. But because the sp3 and the s orbital here, both of them are placed linearly in this bond. They are placed linearly. And we said that a sigma bond is the linear overlapping of orbitals. Sigma bond is linear overlapping of what? Orbitals. So as a result of that, because sp3 and the s orbital here are placed linearly, then we say that the bond formed between the carbon atom and hydrogen atom here is sigma bond. So the bond that we have here is sigma bond. So this sigma bond present here, also present here, also present here, and also present here. So the all four bonds that we have in methane are identical, and they are known as a sigma bond. So thank you so much for watching this video. Please and please and please don't forget, whether on YouTube, subscribe, whether on Facebook, like our page and follow our page. This video is from my prof tutor. Thank you so much.